Talk that I'm going to give today is called Owning a Building. It's really a look at access control and facility management systems. And so hopefully you come away with this. Thanks to Black Hat for having me out here. It's an amazing experience. And hopefully you guys will learn something here. So a little bit about me. That's my handle on Twitter if you want to follow me. If you go to Twitter and look at my bio, it says that I'm a Madagascanese olive smuggler. It's kind of an old story. We can talk about it at the bar. But that is really me. I'm currently Director of Vulnerability Research and Threat Intelligence at Qualys. I had a startup that we basically spun up called Spearpoint that was acquired by another company called Silence. And I worked at Google previously. I was a tech lead for a Google security team called Whoops. Really good experience there. Whoops stands for Web or Other Product Security. So it was pretty neat. I was also a release engineer for Google+. I worked at Microsoft as well. I was a security program manager for Internet Explorer. It's a piece of software you've probably never heard of. But I also did some release engineering for online services, so pretty neat stuff. I have a couple degrees. I don't think it really matters here, but published a couple books. I actually published a book with this guy right here, so co-author. But I think most importantly, I've been looking into industrial control systems over the last couple years, and we have about, it says 30 publicly credited, ICS certified advisories. I think it's a little bit more. And I still think, I did this with a colleague of mine, I still think we are like the top group to have the most ICS certified advisories, if that means anything to anyone. But we've worked with a lot of different vendors. We report over 1,000 different issues to DHS, mostly involving industrial control systems. So some of them will probably never be fixed. And if we find an interesting time, we can probably present some of those bugs as well. But I wanted to talk to you about facility management controls and buildings, essentially. And so why? You always want to ask yourself why. Why is this important to me? So we actually know that buildings are being attacked. So if you look at this ICS CERT monthly monitor from last year, it was the January to March monthly monitor. There's a link up there if you want to take a look at it for yourself. We know that publicly acknowledged, there's 2 buildings that were attacked. Their energy management systems were attacked. So one was a state facility. I don't know where it was, but basically a government facility belonging to a state, so a state agency of some kind. The other one was a manufacturing plant in New Jersey. So, and when you think about these incidents, so the way that I think about it is most of the damage that someone would probably do via energy management system or a facility management system will probably go unnoticed. In fact, if something changes or something breaks, they'll probably just call a technician in, and the technician will probably just change whatever broke. So in order for someone to be called in, specifically in order for DHS to be called in to investigate something, it's probably pretty significant. So if your air conditioning goes out, even if it's a very sensitive facility like a hospital or a surgical center, you might be able to fix it pretty quickly, right? But to have some kind of effect where it's so bad that you want to reach out to some place like DHS, that's probably really bad, right? So the details of what happened here, they're not revealed, but just kind of, maybe pulling some threads here and trying to figure out what happened, to the end organization, it's hard to say. And the reason that it's hard to say is because each building management system is the same, but the buildings that they manage are all different, right? So pretty much every single building that you'll run into, the way that they're configured and the way that the building management system runs the building, whether it's energy management or access control or just environmental control, usually it's done differently from even the building that's going to be next door. So that's something that's very important to understand. So the more you understand about the various pieces, which kind of stay the same, the better. But when you actually take over a building, the facility management system or the energy management system, pretty much every time you do it, it's going to be different, right? So, what is a facility management system? They're very invisible. If you're a Fortune 1000, if you have a corporate campus, if you have a badge reader on a door that you go into for work, you actually have facility management system, building management system, building automation system, whatever you want to call it. You actually have those in the building. This facility that we're in right now has tons of facility management systems in it. So, and it includes things like card access. It's not magic. A lot of times what happens is the little badge reader on the door, it doesn't make a decision by itself. What it does is just collects data and basically sends it off to a controller someplace. And the controller actually forwards that someplace else, whether it's a database lookup or some other type of lookup. Basically does the logic at an application server and then sends data back saying you should unlock or not unlock or do something else. So same thing with video, right? So every modern facility has surveillance. A lot of times what's going to be allowed is the people doing the surveillance can probably pan the camera or zoom in, zoom out, take a look at things, switch cameras. Back in the day, this used to be closed circuit, but all this is moving to IP now. So it's pretty interesting. And a lot of it's managed over HTTP. Intrusion. So when I say intrusion, I'm not talking about like snort or anything like that. I'm talking about like if someone breaks a window or kicks in a door, If it's a modern facility, an alarm is going to go off and someone's going to get notified. The way that they do that is via sensors. When the sensors detect that a window has been broken or a door has been kicked in, it'll actually send a signal someplace saying, hey, something bad just happened. You should either trigger an alarm, a silent alarm, a real alarm, contact security, make a phone call. There's all sorts of different things that can happen. So these are physical intrusion devices. Elevators, when you badge into an elevator with your room key and say, hey, I need to go to the 19th floor or whatever, there's actually a computer on the back end that's making that decision saying, hey, should this person be allowed to get off on that floor or not, right? So HVAC, we're going to cover some of these examples here. For HVAC specifically, this is probably the most common facility management system that we see in general. And the reason this is probably one of the most common facility management systems that we see is not because it's cool, it's because it's very cost effective. So when businesses do HVAC via building management system, they're doing it because it's cost effective. They're going to save money. And I'll give you an example of how they save money. So we looked at a data center here a couple years ago. And basically, if you have a data center, it's going to have building automation systems. The environmental controls for the data center are going to be controlled by computers. Those are facility management systems. Those are building automation systems, building management systems. And what this particular data center was doing was it was basically monitoring the prices of energy. So if it were cheaper to run on fuel, it would switch all the energy to fuel. If it were cheaper to run off the grid, it would switch to the grid. If it was cheaper to pull in cold air from the outside as opposed to just generating cold air via the air conditioners, it would do that. And so what it was doing is just understanding what's the cheapest way to basically cool this data center and constantly readjusting all the time. And this resulted in like tremendous cost savings for the organization that installed these systems. And that's why they did it. They didn't do it because it was cool. They did it because at the end of the day, they know that they're going to save money. And that's why a lot of buildings have building management systems in them, especially things for environmental control. Same with lighting. It's becoming more and more common to control lighting via, like building management system. It's the same reason, just for cost effectiveness, energy savings, cost savings. So, and you can actually do really cool things. So if you live in a building and you share that building with a lot of other folks and you get an electricity bill, it's probably done by a building management system. The building management system understands what your electricity usage is for a given point in time and then basically sends you a bill for that particular usage, right? So it's pretty cool. It's pretty interesting stuff. And so what we're starting to see that's pretty recent is a consolidation of all these different systems. So if you look at these systems in the past, they've all been these different siloed systems that basically never talk to each other. But what we're actually starting to see now is they're all starting to be consolidated together. A good example of something that's already consolidated together in a very meaningful way are fire alarming systems. We've taken a look at a number of different fire alarming systems. So if a fire alarm goes off in like a facility like this, it's going to trigger a bunch of different events. So the fire alarming system is probably going to notify our fire department someplace and say, hey, look, based on the sensors that I have in the facility, I think the fire is this big, it's on this floor, it's this type of fire, whether it's chemical or wood or whatever, and it's going to notify those people there. But it'll also do really interesting things like maybe it'll turn off the HVAC systems for that particular floor. So the smoke won't get put into the ducts and things like that. Maybe it'll turn off certain electrical systems. Maybe it'll disable the elevator. So we're starting to see that these building management systems are starting to be consolidated. They're all starting to talk to each other, and they basically can control each other, which is actually really interesting. I'm going to talk about a couple different vulns here. And the reason I think this one's, there's just a bunch of different vulnerabilities, but the reason I think these ones are interesting, I call this a device password retrieval vulnerability. The reason I think this one's interesting is because all the building management systems I ever looked at have this vulnerability for some reason, where you can actually just touch the building management system remotely and pull the password out. So I don't know if it's like one person basically working on all these building management systems, or if it's just some weird thing or design the way these folks are taught. But we've come across a couple different ones. So these two building management systems that are presented up here, the Niagara Framework and Metasys, they're probably two of the most popular building management systems in the world. So, and so for the Niagara, basically an authenticated user can retrieve the device password. That's just the end of story. Device password's actually encoded, so it's not encrypted, it's not hashed or anything like that. If you know how they encode it, you can decode it. So we know how they encoded it, so we can decode the passwords. And then once you decode the password, you can have the clear text password. You can log in with any account that you want. You most likely want to log in with the administrator account. And so whatever system that building management system is running on, it can run on 3 different platforms. It can run on Windows, it can run on QNX, and it can run on Linux. Right? So if you get it on a Windows box, you'll have system. If you get it on a QNX box or a Linux box, you get root. So because the framework is running as root. And that's pretty cool because you get root on the underlying device. Right? So if that device is connected to something via unauthenticated protocol or clear text protocol like BACnet or Modbus, whatever it's connected to or whatever network it's on, you'll be able to talk to those devices as well. If it's a Windows machine, since your system, you'll be able to extract any kind of creds off of there. So if an admin had logged into there, or domain admin or something like that, you'll be able to get their password off. That's kind of neat. Same with the Metasys device. An authenticated user can retrieve the device password. In this case, the password's actually hashed, SHA-1. But you can also do an authenticated password reset for any user. So if for some reason one of the users, like the admin user, has a really stout password, you could just password reset them and then log in with any password that you want, right? So essentially that's an authentication. Well, essentially that's an authentication bypass, but there are other bugs that just allow you to do authentication bypasses, call various things to interact with the device and make it do things. And then there's also a way to compromise the underlying system, which is always interesting because the frameworks are really good. In fact, they're developed to allow engineers and operators to easily manage the devices that they're connected to, right? Because you don't want engineers to have to write Modbus or BACnet every single time they want to adjust the temperature point for an HVAC system. So you want to make it very easy for them. You want them to literally click a button and type in a temperature and have that temperature point set to an HVAC system. So if you can compromise the underlying system, you don't have to worry about any of the restrictions that the framework puts in. So if the framework has some type of restriction that says, hey, I don't like it when you send malformed Modbus or BACnet to that particular device, I don't want to allow that. If you've compromised the underlying system, you can just do it yourself. You can just do whatever you want, right? So compromise of the underlying system is always interesting when it comes to devices like this. And then, of course, for lateral escalation reasons, compromising the underlying system is always important as well. So this is the Tritium Niagara framework. It's on this device. This is what they look like. It's like an industrial box. It's like a steel box. You'll probably find it in a closet someplace. This is Johnson Control Metasys. This is a little controller. You'll probably find this in a closet someplace as well. This is not something that you would see like mounted onto the wall in your hotel room. This is actually the controller. So the thermostat and the environmental controls in your room would actually communicate to this device someplace in a closet somewhere. So the first thing that we want to talk about is physical security, because much like regular computers, if you have physical access to one of these devices, the controllers, it's game over. It's by design. Every single vendor, every single person acknowledges that. That's why they always recommend that you lock these things up and don't allow anyone to have physical access to it, right? So a lot of times they'll have console access, or if you can get to it, you can either plug in, usually via serial, RS-232 or RS-485, and you'll just have a shell essentially on the device, usually at a very privileged level. So the technician and services passwords, they almost always work when you have physical access to the device. So if you know a technician or service credential, you should be able to log into this device pretty simply. And then most importantly is whatever network it's connected to, if you have physical access to it, you'll have access to that network as well. And the reason that's important is because you'll have access to things like BACnet, the building automation and control network. It's an unauthenticated protocol. It's clear text. So basically, devices are just sitting listening on this network, the BACnet. And if you get onto that network somehow, you'll be able to talk to all the devices on the network. That's just the way it's designed. So, and the cool thing about that is a good friend of mine, Michael Toker, he actually wrote a script to enumerate BACnet devices, and he put it into Nmap. So you can go to Digital Bond's website, and you can actually download this Nmap script. It's intended to be run on an internal network, but nothing is stopping anyone from running it on the internet, right? So in fact, if you do run it on the internet, you will actually find BACnet devices listening on the internet. So this particular one is a Biomed boiler system. So, and as you can see, with industrial control systems, oftentimes they like to give up a lot of information about what they are. So the way that this enumeration actually works is pretty clever. What Mike basically did here was there's a way to query a system where it's in the spec where the device will actually respond with an error, right? And so if you see that error message, you know that it's actually a BACnet-enabled device. And then once you know that it's a BACnet-enabled device, you can actually query it for information like this. Right? So this is the Nmap the Nmap script that's there. So anyone can download this, and you can actually start running this on your internal network to find out where your BACnet devices are. So pretty interesting stuff. So the physical access piece, it's extremely important, right? Because once you have access to the BACnet, the Building Automation Control Network, you'll be able to talk to any device on the network. So, and having physical control over a public building is really hard, right? It's very, very hard. So take this device here, for example. It's a little hard to see. This is actually a thermostat. And on the bottom, it's got a RJ45 jack. So it's not like a network jack. This is actually a jack to basically jack into the BACnet. But this device actually, here's probably a better picture. Does anyone know where this device was, where I took this picture at? Where's that? No, it was not here. No. This was taken at Atlanta Airport. So hundreds of these thermostats everywhere, right? And if you plug into one of them, you get on BACnet. You can talk to any device that's on the airport BACnet, right? So pretty interesting. So what about this one? Anyone know where I found this one? This one's really dirty. Like, this is the dirtiest thing I ever saw, and that's why I took a picture of it. I was like, that's pretty interesting. So, because there's hundreds of these, hundreds of them. This is, see, like I said, it's really dirty. So same thing, RJ45 jack on the bottom. You plug into that thing, you're on BACnet. This is actually at Salt Lake City Airport. So if you have a public facility and you have things like this, I'm telling you right now, it's almost impossible to keep someone off the building automation control network, especially if you have access points like this where someone can just plug in. And so more about the vulnerabilities. So the Niagara framework, we reported a couple different vulnerabilities to them and said, hey, you really need to fix these. And so they did. And so some of the vulnerabilities that we came across, the password retrieval, even the way that they store their passwords, the encoded way that we called it encryption, they actually fixed it. Now they hash their passwords and they use Assault. So it's pretty cool. So I'm going to show a couple slides here about the, about the vulnerabilities, but if you actually download the latest patch, those vulnerabilities don't work anymore. So that's pretty neat. Metasys, on the other hand, we contacted them in November. We always contact people through DHS, right? So we have a third party that can kind of track and say, hey, this is when they notified us or whatever. So that was April 22nd. And we never heard back from them. So actually until last week. They're like, hey, what are you guys going to talk about next week? I'm like, I don't know, maybe your device. So, but if we look deeper into Metasys, which is what we're going to kind of deep dive into today, the device that we have actually runs WinCE. So that's actually really, really interesting because a lot of the tools that we have can basically disassemble anything that we have in WinCE pretty easily, right? So in fact, when we load a lot of the portable executables into IDA Pro, it says, hey, these are x86 executables. So that's pretty cool. And then some of the files are actually .NET assemblies. We're going to look at one of the .NET assemblies here in a bit. And so if we look at the file system, so if you get one of these devices, you get access to a device, or you have some kind of exploit or whatever where you actually own a device. When we look at the actual way it works, it's an embedded device, so there's a flash on there. It's not a drive. You can't go to like C:, or anything like that. It just says /, right? If you go to /metasys, that's where all the audit logs and configuration files are, right? So that's pretty important. There's also another directory called metasys/securedb, securedb.xml. That's a file. Those basically contains all the users and passwords to the device in an XML file. They are hashed, right? They're SHA-1. So there's an account on a Metasys device. It's on every single Metasys device called Metasys SysAgent. That is the Metasys system agent. That is user ID 1. That is essentially the admin for Metasys devices. That's the user account name. And so when you look at the securedb.xml file, this is what you'll see. So you'll see the user ID of 1. You'll see a table of users, user ID 1. And you'll see a lot of interesting things. Like, for example, there is no account lockout for this account, right, because it's admin. And this account essentially never expires. So pretty neat. And it can't be, it's not disabled, obviously, by default as well. So I guess you could maybe change these. I don't know what it would do if you disabled the sysadmin account. I'm not sure. The sysagent account? Not really sure. So most obvious things. The version of WinCE that is running on the Metasys device actually has a shell where if you just telnet to it, it'll actually drop you into a shell or your system, right? So if you're actually looking for these on the internal network, that's probably the easiest way to own one of these devices, right? They also usually have unauthenticated FTP open as well. So you can FTP into it, grab the securedb.xml file, get all the passwords, crack all the passwords, whatever. So pretty interesting. But probably don't have to do that because you have the telnet, which gives you a shell anyway, right? So pretty neat. And I don't know who made that decision, right? But like, this is what needs to happen. Like, no more for you, right? No more. So a little bit more about the file system. There's /storage. That contains a bunch of crash dumps, and it contains a bunch of memory dumps as well. So if the device ever crashes for any reason, that's where those files are going to be held. Those are pretty interesting, especially maybe if you're doing forensics or something like that, to see why a particular device crashed and what caused it. So storage /metasys/preferences, that's where the user system preferences are stored. Very interesting. And then there's another directory, storage metasys securedb. It has a copy of the securedb.xml file. If you don't want to use the XML file, you can actually use a real database file. It's an SDF file, which is basically like a compact file format. You can connect to it via just regular database driver and basically query it. It's basically the same thing as a securedb.xml. It's got the usernames and passwords and some of the configuration stuff for users. So, but what's important to me is the thing that's probably going to be facing if someone tries to lock down the shell and the FTP is the web interface, because that's how engineers and operators actually manage these devices through the web interface. So if you look at storage, metasys, www.root, /metasys, xxx, the X's are actually the versions. That's where the application logic for the web interface is. So very interesting to me. The web root actually contains like 50 jars. And if you actually connect to the web interface, those jars will get downloaded to your local system. Metasys does this, Tritium does this. I don't know why they do this, but it ends up putting like 50, I think in some Tritium installations, it'll put like 100 jars on your local file system. So it's on the server, but they'll also get pushed to your client, so which is pretty crazy. And then so if we look at /WS, there's actually web service code in there. That's pretty cool. And so if we look at how the application logic is implemented, if we look at /WS, which is for web service /bin, we actually see precompiled .NET assemblies in there. So they don't just have like ASPX files where you can just read the source code, right? But anyone that knows .NET knows that it's IL, so it's easily like basically reversed, right? So you can get the source code if you have the binaries, if you have the DLLs. I'm not sure if the engineers at Metasys were aware of that or not, but so as soon as you get the DLLs, you can basically get the source code for all the DLLs. So and reversing the binaries actually revealed some pretty interesting bugs. So when we look at the .NET assemblies, we see things that will retrieve a directory listing from the device, which is pretty cool. Upload arbitrary files to arbitrary locations, which is really neat. There's also web services to retrieve user information, including the password hash, right? Because retrieving a password hash is a really highly requested feature. It's super popular, right? So every device should have some web service to retrieve a user's password hash. And so if we take a look at webservice.common.dll, this is what we see in .NET Reflector, right? So there's a bunch of different classes in here. Probably the most important to me right now is .security, right? So if we take a look at .security, it has a bunch of different methods that we can call, one of which is administration service. And if we look at a lot of the things that are stored in there, we see basically like a method called getUserProperty, which takes an int, which is a user ID. So this is pretty valuable since we know that the Metasys sys agent is always user ID 1. That's pretty cool. And if we look at the description, it always returns a property for a single user stored in the database, whether that's the XML file or the actual database file. Pretty interesting stuff. So if we look at a different DLL, subsystems.common.dll, we see that it also has a .security as well. And if we dig a little bit deeper in there in subsystems.common.dll, we see a function called principal store, right? And this is basically where usernames and passwords and user information is getting written and retrieved from the device. So never mind the intracomputer user and the Metasys sys agent default password. Don't worry about that for now. Pretty straightforward. But the principal store is pretty interesting because it takes a user ID and a login name. And then if we look at how that thing actually works, essentially it just grabs all the information about a particular user and just puts it in an object. And so if a web service ever calls it, it'll just return this giant blob of data, which is really interesting, right? So principal store getUserProperty. And so the way that we would actually call this web service is just by going to the security/admin-service.asmx web service and just doing a simple post request like any good web service and just say, hey, I want to use getUserProperty and give me user ID 1. And it'll give you a response like this, right? The most important thing is likely the username and, of course, the password hash for the device for that particular user, right? Pretty cool. So writing a web service to retrieve a user password is pretty bad, but it gets worse if you just forget to do one thing. Does anyone know what that one thing is? If you forget to put the web service behind authentication, right? So if the web service is available to unauthenticated users, then anyone can retrieve the password hash for any user on the device, right? And so I was like, wow. And so last week when they're like, hey, we're interested, when Metasys actually contacted me again, they're like, hey, we hear you're going to give a talk next week. Sorry we hadn't talked to you in the last 3 months. But we're just kind of interested in how you would fix this vulnerability. They're like, we know how we would fix this, but we're just kind of interested in what your thoughts are. And I was like, well, first off, you probably don't need to retrieve people's passwords. Second off, you should probably put this behind authentication, right? So, I was talking to the guy, I was like, wow, whoever wrote that web service, had one job, right? Hey, you had one job. You had one job, right? You wrote this web service and you forgot to put it behind authentication, right? You had one job. Like, man, that's pretty bad. So that's pretty cool, though. So when you get a username and a password and you log into a device, this is what you'll see. And so this is interesting because I always want to show people this because a lot of times people are very intimidated by things like building management systems, facility management systems. They think it's this weird thing, where you drop in and it's like totally, you can't comprehend what's going on. It's the furthest thing from the truth. In fact, when you log into a modern building management system, you're going to see something like this, right? It's very user-friendly. It's usually just a web interface where you just say, hey, look, I want to push this button and reset this set point for this particular device or do whatever it is. So if you drop down to the underlying device and you want to communicate to a device in a way that's not intended to be communicated to, things get a little bit more complicated where you actually have to understand the protocols and all that sort of stuff. But for the most part, if you want to do a lot of damage to a building and you log into the building management system, you just have to point and click. So it's pretty straightforward. And so I want to talk to you about how prevalent these building management systems are on the internet, right? Because this is actually really important. It's probably the most important part of the whole talk. We basically created this enumeration effort to find as many building management systems on the internet as we could. So initially we based off Shodan, but we moved to some custom scanners in EC2, right? So we found like 50,000 buildings, right? Most of them are exposed to the internet, or they're exposed to the internet. Most of them are outdated, right? So we can run exploits against them, basically take over the buildings in any way that we want. So stadiums, hospitals, police stations, prisons, military installations, like everything you can imagine. In fact, I brought with me Excel spreadsheet of stuff that I found on the internet. We can just, if you want to, I'll just let you guys say, hey, I want to search for a police station. And I'll just Control F and we can find police stations. So all total, probably about $500 to buy the devices from eBay end to end for the EC2 time, right? So not too expensive. Okay, so they're actually really prevalent on the internet, right? And so what I'll show you here is some stuff that we've done. Okay, so this is my list of stuff, right? So hold on. I'll go to the top. And so what do you guys want to search for? I've actually looked at stuff in Singapore. So there's like some health agencies that I found. This spreadsheet that I have actually doesn't have the location. I could easily do it, but and usually when I search on Shodan, I do it by location as well. That's probably the best place to. That's probably the best way to find stuff. But this just has names, right? So we just have to basically pick names. We can find things with certain names, right? So how about like bank, right? That's a pretty popular one, so bank. So there's one right there. There's another one right there, right? So there's one right there. Okay, so lots of banks, right? So those are not names that I picked. Those are station names. So the devices have these names inside of them, right? And I'll show you how we got these station names here in a second. So anything else? School? Don't ask me. I don't know. School? There's definitely a lot of schools. Schools are very popular. Yep. Tons of schools. Defense. I don't see any defense in there. Oh, okay, thank God. Good. We hospital? Let's see, hospital. Some hospitals. Definitely some hospitals. When I say Fox, it's basically a protocol that I'm using. Johnson is basically a big integrator, so I just kind of tag these because I think they're interesting. So, well, let me show you how I got this data. It's pretty straightforward. So, have some tools. Basically, a really simple script. I just get IP addresses for things that I think are building management systems, or you could just scan the entire internet, like all the IPv4 space, and you can just say, hey, run this Python script, right? And so it'll just take that list of IPs, and it just looks up basically, like the BACnet thing that we saw. There's another protocol called Fox for certain particular building management systems. I just query that service and just say, hey, give me all the data you have about you. And so what you basically get is something that's returned like this. So at the top is basically what we call the station name. So it says Fox. That's just a tag for me. DSC_WS. Not really sure what that is. But it tells us a whole bunch of information, right? So for example, this thing's running on Windows XP, right? So that's pretty interesting. It also tells me the exact version that this particular building management system is running as well. So which is extremely helpful if I have a bunch of different exploits. I know which exploits will work, right? And it tells me what time zone it's in. It also tells me what the license ID is for a particular device, right? So I have another tool where I can take a license ID. Let's see, mark. So this is the license right here. So I have another tool where I can say, hey, given a particular license, I want to look up what's basically enabled for that particular license, right? So this XML file is the actual license that the customer would purchase. And the cool thing about this license is it tells you all the features that they're authorized to run, right? And so if I find a particular component or if I'm looking for something in particular, I can basically look at the license files and understand what it is that I want to go after. So for example, like NRE drivers, right? NRE drivers may only be used for certain things like, let's say, power metering, for example, and I just want to look at power meters. I can just say, hey, give me all the licenses that have NRE enabled, and then you can just start from there, right? Pretty cool stuff. And then at the bottom is basically a different way of parsing the data. And so we didn't know what DSC was, but now we do because we know that the project for this device is actually Doctor's Surgery Center. So we just enumerated the building management system for a surgery center, right? So that's not good. That is not good. I don't know if I need to tell you that, but that is not good. So pretty interesting stuff, right? So the good thing is I was going to share the Python script with everyone and say, hey, look, if you want to enumerate this stuff, here's this Python script. But then everyone will be running this like scan across like the internet trying to find these buildings and stuff. And so instead, what we did is I just talked to the guys at Shodan. I said, hey, why don't you guys just do this? That way no one else has to scan for it. And so we take a look at this, and this is basically how you would query it. It's the same information here, right? And there's 15,367 buildings that can be identified with just this method, right? So not every building management system has this particular method enabled. So as you can see, there are a lot of buildings online. So the top one there, University of California. But what I want to actually show you here is this is actually more interesting to me here. So let's take a look at this one. I know it's kind of hard to see. But if we take a look at this particular one, the station ID is North Star Financial, right? So I'm guessing that's some kind of bank, right? Let's take a look at the one below it as well. So this is a good one too. Hotel Diamond, right? So that's pretty interesting. And then if we take a look at this one here, Pier 80 Admin, right? So it could be a variety of things. This one here is Vine 500. So, but the reason I want to point that out is because if we look at where these IPs are, forget the geolocation just for a second, but if we look at where these IPs are, they are not in an organizational IP space. It's actually in an ISP IP address space. So this one is Cox Communication. This is North Star Financial. So it's not in North Star Financial's IP blocks, right? And if we look at Hotel Diamond, it's in AT&T Internet Services IP address space. So it's not in Hotel Diamond's IP address space, right? This is really important. So if we look at Pier 80 Admin, it's not in Pier 80 Admin's IP space. It's in AT&T Internet Services space. And the reason that this is the case is because when you buy a building management system, you don't have your employees install the building management system for you. You always hire a third-party contractor. That guys in hard hats come in and they install it for you, right? And those folks are known as integrators. And so what these integrators will do is they'll take down your requirements. So for a place like this, they'll say, hey, look, I want it to be cool in every single room. I want the temperature variance to be this and this, and I want to be able to turn on and turn off all the ACs for all the single rooms from one centralized location. And the integrator goes, I can do that. And they pick out the particular devices that they want to install, probably one of the two that we showed you here, or maybe some variant of it, and they'll install it into the building, right? And then what they'll do is sending someone out to a building to basically do maintenance is actually really expensive. So what they like to do is take a cable modem or a DSL line, walk into the closet, run a line to it, and hook their building management system up to the DSL line. That's why we see so many building management systems in commercial IP, ISP IP spaces. So in fact, if you're looking for your own building management systems online, it's probably not in your IP block. The only place I've really seen them in an organizational IP block are schools, like this top one here. This is California State University Network. So universities, for some reason, they have their building management systems in their own IP blocks. For everything else, it's usually in a commercial ISP space someplace. So if you're looking for these systems, scanning your IP block is probably not the way to go. Instead, what you'll need to do is basically scan the internet and look for other metadata that's associated that could be your system, right? So let's see if there's any other ones here. Pretty cool stuff. So a lot of stuff on the internet. You can go to Shodan now, and instead of running Python scripts, you can actually look up stuff as well. So it can be on by IPv6. Yeah, it supports IPv6, definitely. Yep. IPv4 is much more common, though. So just kind of a run through of the exploit. So there's a bunch of different vulnerabilities where we can pull down various configuration files. This one's actually patched. This is what the configuration file for a Tritium system looks like. So we can pull this thing down. There's a section here that has the usernames and passwords. The password's encoded, so we just get the encoded password. If we know how the password's encoded, we can just decode it. So this password just happens to be decoded to anyone's guess. So pretty interesting. I don't think I'm going to release this tool. I don't know how productive it is, but you can find these things. It's very trivial to write yourself. So it's patched, though. And so some of the more interesting control systems that we've seen, like building management systems, really cool, right? Like this one right here is an HVAC unit, right? So the user interface is actually really intuitive on how you use it. So something like that's also pretty cool. Boiler system, right? Really cool. This is probably one of my favorite ones, like Gable's Residential Tower. It's like, man, you can just take over this whole building. It's pretty cool. Golf Galaxy. So the reason I have this screenshot here is, once again, we're talking about how all these building management systems are kind of consolidating. So when we take a look at this particular facility management system, we see a bunch of different things there, right? So we see site emergency phase loss, outdoor temperatures, all this stuff, and then we see security systems. So this is an instance where the security system is actually tied into the facility management system, right? It's pretty neat. And so that way we know that if we're able to actually compromise the underlying device, we can actually talk to security systems if we want to. What those security systems are, I'm not sure, but pretty interesting stuff. So this one's really cool as well. Does anyone know what OCPP is? Open Charging Protocol, right? So this is like an electric charging stand someplace. So that's pretty neat. And then I guess those white lists right there, that's like badges of people who can't go up to the charging station and actually use the electricity. So pretty cool stuff. We found this one a little while ago. I was very surprised. It was available to the internet with no authentication. We actually have a list of buildings. There's about 2,000 that we know of, where if you can just guess the IP address, you're actually on the building management system. So this is one that we found. It's pretty interesting, right? We're like, wow, it's pretty cool. So yeah, we're like, oh, that's pretty cool. And we're like, why would they set this up? But back here, this is the environmental controls. So like all the different sections that they have for the arena, basically that's the environmental control for them. I'm thinking probably the most important pieces would be like the equipment room where the temperature has to be like highly regulated maybe. I don't know. But this is probably more important. This is a breaker status. So when you look at PR5, those are actually all the breakers that are on or off at any given moment, right? So this is attached to breakers. It's pretty interesting. So those are breaker status right there. So there's some UPSs over there, UPS 1, UPS 2, and there's some other things, PR5. There was like 10 of these, PR1 to the PR10, so a bunch of different things. And then using the tool that we had, we can identify exactly who installed this thing. LA Installations, we contacted them on the phone. We said, hey, dude, you should probably take this thing offline. The station name, which is important to give us context, because this was in a commercial ISP space, right? So if we don't know like station names or things like that, it's kind of hard to tell who the thing belongs to or what facility it's being used to run. And then, of course, we have the time zone, which just helps us confirm, like, yeah, this is probably actually for real. And later we found out that it indeed was real. And the reason this device was actually put into place is because the Olympic broadcasting folks needed a building management system to be comfortable while they're doing all their broadcasting. So they took it offline pretty quickly. So pretty interesting stuff. Running Windows 7. It's kind of neat. And so let's take a look at some of the building management systems on the internet. So I have a list of about 2,000. I'm not going to share all 2,000 with everyone, but if you look hard enough, you'll find them yourself. So, but let's see what we can find here. I have a VM here set up. We can take a look at what it's like to basically interact with the building management system. So if you were to run an exploit, like password retrieval, and basically pull a password down, decode it or whatever, crack it, and then log in, this is basically what you would see, right? And so this one's pretty cool. No authentication. Like you just browse to the IP address for this one, because I can't run an exploit against an internet-facing system, right? I'm not going to do that. But I have a list of 2,000 systems where if you just guess the IP, it drops you into this, right? So basically, if you run an exploit, get the password, or if you just find one of these 2,000 IP addresses and go to the IP address, it actually drops you into the building management system, right? So what I like to do is, there's a file folder for this particular building management system. There's this PX. This is like the actual user interface files, right? And so what we want to do is basically say, hey, look, I want to take a look at the first floor and the mezzanine here. So, And the way that I would do that is just go views, and then WBPX view. And basically what's going to happen is it's going to load that interface for me. So, and the interface is just much more valuable. But you can see, based on the left-hand side, I'm not limited to the user interface. If I wanted to do other things, there's a lot of other things that you could do without being limited by the user interface, right? In fact, if I wanted to, I could just privilege escalate and own the underlying device itself and then do whatever I want to any of the attached devices, right? And so the cool thing is once you kind of look at some of these building management systems more and more, you start to understand what all this stuff means, right? And so like if we look at second, right, which is probably the second floor, a lot of these things are separated by floors and zones, right? But it's just a way of kind of separating particular devices out and things like that. So taking a little bit of time here to load. But and this is all based on Java, so that's why it's so slow. And that's why I'm running this in a VM, because there's no way I would run this on my regular box. So, yeah. But a lot of times what you'll see, once this thing loads here in just a second, are things like this, which are floor plans. It'll show you this. It's going to render here in just 1 second. It'll show you a floor plan. It basically shows you like all the environmental controls for this particular building, right, and what is running where. And obviously, you can change some of this stuff. But what's also cool, so after everything gets loaded, yeah. So as that thing is loading, we can look at another one, right? So this one's pretty cool because what the integrators actually like to do is actually tell you what building it's managing, right? And so they'll have a picture of it and saying, hey, this is a building that's being managed, right? And that's the address. So if you wanted to stand across the street and be like, this is awesome, you could do that if you wanted to, right? And once again, it's pretty user-friendly. It's a little slow, but I'll go in here. Let that thing load. Is this thing loaded here? Like I said, it's Java, so it takes a little while. I tried to load these beforehand. Let me see if we're actually still up. Okay, we are. It's just taking time, that's all. Yeah, a lot of these have like little animations and stuff to kind of tell you what's going on. Let's see, I want to look at these guys here. PX. Let's look at the pumps. This guy. So once again, the user interface is pretty intuitive. And a lot of times what they'll allow is they'll just allow you to basically to change commands on the bottom, right? So if I hover over this thing, I'm not going to click it, but if you hover over this thing, you'll actually see that there are buttons, right? And so this is how an operator, like a real engineer, would actually manage a building, right? And so, so if you put your building online to the internet without no authentication, anyone can manage your building, right? So it's pretty simple. Yeah, I'll talk about alarms here in a second. This is pretty cool too. This like loop pump control. Let's load this thing up. So alarms, in most cases, when you see the word alarm in a building management system, it's not like a physical alarm that's going to go off. What folks usually do is they'll set up criteria to be notified for something, and that's considered an alarm. So if a temperature gets too high, or if a temperature goes too low, or if something is turned off at a time it's supposed to be turned on, they can create an alarm. And so what will happen is if that criteria is met, either someone gets an SMS message or a phone call or something like that, and an alarm goes off. So when you see the word alarm, it's not usually like a real physical alarm going off. It's just like a set point, yeah. So this is pretty cool. Once again, you can like hover over the command. And so if you want to click that thing, you would turn the pump on, right? It's pretty straightforward. The way that this actually works is they code this interface. If you click this button, it passes a command to the underlying framework. The framework basically translates that into whatever protocol is attached to the actual device, whether that's BACnet or Modbus or some other custom protocol, and it sends it out to the device that's listening. In this case, it would be some kind of pump. And then the pump understands that protocol, either turns on or adjusts a set point, and responds back saying, hey, I'm on now. And then this user interface just displays it in a nice way. So that's all this user interface is doing. So if you understand the underlying protocols, you can actually jump to the underlying system and tell the device to do whatever you want, right? So in this case, there's only one command really, right? Like turn off and turn on, right? But if you wanted to, you could jump to the underlying device and say, hey, turn on and spin really fast. Or don't ever turn on ever again. Or run an exploit against the device. Because I'm telling you, devices are not very robust. They're not meant to be messed with in any ways. So let's see if this thing loaded. See, this is also really cool. The chilled water system. It just kind of shows you what's going on and off, enable statuses. And then I wanted to load up one other one here, this one right here. So here's one with lights. right? There's employee lights here, customer lights, outdoor lights. This one also actually has energy management as well, right? You can turn power on and off, that sort of stuff. So that's what building management systems look like, right? And I'm telling you right now, if you're a Fortune 1000, or if you have a corporate building, or if you have a corporate campus, you have these systems somewhere. I'm telling you right now, you have these systems somewhere. Hopefully you're not one of these guys that we pulled out that has no authentication to theirs, but you could be, right? So I hope you're not. And so, how much time do we have here? Okay. So a little bit about access control systems. I had a demo for this access control system, but I'm not going to show it because the vendor asked nicely and was pretty proactive, and none of it's fixed. I will talk about one little piece, though, but I want to talk about the systems in general. So for the most part, when we think about access control, we think about these devices, right? Like you badge into a door someplace, it does some signaling, it tries to identify who you are and sends it back to this device, and then a door magically unlocks. It's pretty cool. So I had access to one of these systems here. I thought this one was really cool, right? Because you put your hand on it, and then you badge in. It checks the badge to see if it's the right badge, but hey, someone could have stolen your badge, right? So, and then it basically reads your handprint and says, oh yeah, this is really Billy. We should let them in. So the crazy thing about it is every single one of these devices can be opened with that key. So yeah, that key right there. So that key cost me like $6. So yeah, so super expensive. I know it's probably out of most people's price range, but if you really want to get access to some of these doors, might be useful, right? So, and so if you actually pull that thing off the wall, you'll see that there is not a magical unicorn there making a decision as to what should happen. Instead, there's just wires, right? And so, and this is kind of the heart of it, right? The building management systems, a lot of people are very intimidated by them, but at the end of the day, they're really just computers communicating over networks, right? And so they may be using weird protocols or weird, kind of like weird networks, but it's really just computers over networks, right? And so, and this one has this is the reason I have the screenshot here, is it actually kind of describes what is going on here, right? And so for the most part, all that's happening is once a decision is made, usually not by the system themselves, they can make the decision by themselves. They can have a user database on the actual device itself, but for the most part, they don't do that. For the most part, the decision is actually made somewhere else, right? And basically a signal gets sent back saying, yeah, you should let them in. In some weird cases where maybe you have a remote station that's way far off and the user list doesn't change very often, you can actually put the user list on the device itself, but that's usually not the case, right? And then if we look at some of the wires here, like the outputs, wire 5 and 6 basically control the door lock. That's just as simple as that. So usually it's just about applying the right voltage to the right wire. That's all it is. If you have physical access, right? Because if you have physical access, it's pretty much game over. So in a simplified way, if you go to like a badging system or something like that, and you badge in, what's going to happen is either over serial or IP, a signal is going to get sent to a computer saying, hey, this person just badged in, and this is their number. And usually the application server is going to look up on a database saying, hey, does this person exist in my database? And what are they authorized to access? And it's going to send it back to the application server saying, these are the permissions for that particular user, right? And then back over serial or IP, it's going to send this signal back to the device saying, hey, this is what we know about this person. And then the device actually just applies voltage to a particular lock and says unlock or lock or whatever. So usually 5 volts or 12 volts. Pretty straightforward. So physical access trumps everything, right? So if you go to a badging system and pull it off the wall, there's just going to be a wire behind it, right? Not unicorns, just a wire. So, and typically, some of those wires are actually going to go to the lock. And usually it's just 5 or 12 volts applied to that wire that's going to open that lock. Or sometimes it's a serial replay because the door may have a controller itself, right? So a controller connected to another controller. So obviously it requires physical access. And then this usually requires disassembly of a device, right? You usually have to take a device off the wall. So you have to be really careful about tamper alarms because these manufacturers know that if you take the device off the wall and gain access to the wires, that it's basically going to be defeated. So a lot of them have tamper alarms where if you pull the device off the wall, or if like I did when I unlocked the device itself, it actually has a tamper mechanism that will send a signal to the application server saying, hey, someone just unlocked me and just opened me up. So you have to be careful of that. Typically installed on Windows machines, this is the application server itself, right? So probably the most popular access control software are these 3 here, right? With the top one, probably the most popular access control system that I've ever seen, Secure, right? They have a lot of different versions. Every data center that I've ever been to uses Secure. Every single data center I've ever been to. So if you're doing an internal pen test, and you basically want to gain access to some of these systems, or you want to gain access to some door someplace, or gain access to a data center or whatever, because the physical is in play. And let's say you have something like domain admin. This is how you would find it. This is how we find these things. So we know what the uninstall keys are for these devices. And so if we have privileged creds, we can just say, hey, tell me where this thing is installed. And it'll tell us, like, hey, there's a secure database installed on this particular machine here. And then once we gain access to the machine, once again, it's a human-machine interface. It looks just like this, right? So this is secure. Or actually, sorry, this is door.net. Sorry, carrydoor.net. So, and when you want to unlock something, this is real. We actually did this during like a pen test, physical pen test. You literally just select the door that you want and click unlock. See the little top, the GUI? It's pretty cool. So you don't have to understand the underlying protocol or anything like that. Although if you were really elite, you could understand the underlying protocol and just send it yourself. Or you can gain access to the GUI and press the unlock button, and the door will unlock, right? So it's pretty cool. Adding rogue users to particular groups, it's usually pretty difficult to detect, right? A lot of people aren't looking for that stuff. So just some basic general information about secure. Like I said, that's probably the most, if you're a Fortune 1000, you probably have secure, probably. sysprogress, that's the database administrator account. So if you find a SQL server that has sysprogress account and some weird tables I'll show you here in a second, or like secure SQL, that's the default database name. That's probably a secure database server. That means that is controlling your access controls for your facility. If you own that database, you basically own all the access control for the facility. So for carry, there could be a file for carrydoor.net, or it could be in a database. The name is usually DHS underscore main, and it usually uses Windows authentication, right? So it doesn't have its own account that it usually uses Windows auth, but you can change that, of course, if you want to. So database structure is kind of complicated. So this is the database structure from a secure database, the backend. So, and it stores a lot of different things, right? But probably most interesting to us are the T card, which is the card information, the journal, which is basically everything that's going on, and the person, right? And also a person has all the card numbers and a particular PIN for the card. So all stored in the database. Pretty neat. Pretty neat stuff. So we're getting real close here. So if you're asking yourself, hey, I want to audit my organization, where do I start, right? So we gave you the Shodan stuff. You can go do that right now and look for your organization online via certain protocols. The BACnet scanner is going to be, actually it's already out, so you can go download that and start end mapping stuff. Try to find some of your facility management systems on the internet or the internal network. Or what I like to do is go to your facilities department. So, because a lot of times this is not run by IT, it's actually run by your facilities department. And say, hey, where are our Tritium boxes, right? Where are my Johnson control boxes? Where are my automated logic? Where's my Delta controls? You know, and have them tell you where this stuff is, or give you the software so you can take a look at it and audit it, things like that. Cool stuff. Those are facility management systems. You're probably using one of those for. If you want access control stuff, go to your physical security folks. Instead of saying, hey, you can have access control, just say, hey, where's the secure database? Or where's the secure software? I want to see it, or I want to take a look at it, or where's the license because I want to audit it or do whatever. Or carry, or slot, right, hand net. So. Or if you have domain admin or privilege creds, you can just scan for the class IDs, which we gave in the slides here. So for the surveillance systems, physical security folks, these are the systems that you would ask for. But the best people to ask are your data center folks, because they have everything. They have everything you can imagine. They have the facility management systems, they have the access control systems, they have the energy management systems, they have everything. So if you go to your data center folks and say, hey, I want to take a look at all the software, they probably have it, and they probably have it implemented. But you have to ask nicely, because otherwise they won't give it to you. So I do want to take some questions. Any questions? That's hard. So that is one thing to kind of keep in mind, right? So yeah, exactly. Control Z. So that's a really good question. One thing to keep in mind is I've always classified building management systems and facility management systems as ICS, industrial control systems, right? So it just kind of falls under ICS. And ICS almost always controls a process. So you have computer systems and other systems, embedded systems, but they are there to control a process, right? And so undoing software mistakes is pretty easy, Control Z. Undoing a process mistake is hard, if not impossible. So if you are auditing these systems and you turn something on, you can't take that back. It is a physical event that has occurred someplace, right? So you cannot undo that. You can turn it off, but you may not undo what that process had caused, right? So if you are doing auditing against these systems, you have to be really careful about that. And you always have to understand that the interfaces, while it looks very cartoonish and it looks very innocent, it's actually controlling a process someplace. So if you turn on a boiler, like the fire is going to get lit, right? And you won't be able to make it sort of like, I don't want to ever have done that. It's too late. It's a process that's occurred. You can't take it back. It's not a VM where you can revert back to a snapshot, right? So very good question. It always controls a process. So you always have to keep that in the back of your mind. Yeah. Anything else? Yeah. That's a good point. Usually when folks, did you guys hear the question? So the question was, it's likely that most chief security officers don't understand that this falls under their purview, essentially. So they don't understand that this is a risk. They don't understand that the building's online. They don't understand how to find it. There's no software to go manage this sort of stuff. That's actually a really good question and a really good point, because usually when we talk to folks and they're like, how can we get a better handle of our facility management systems and how do we secure these things? Do we need to change passwords? And I'm like, well, the first step is to organize yourself in a way that you can manage these things. So the last couple slides that we had, it said, hey, go talk to your facilities guys, go talk to your physical security guys, go talk to your data center folks. Usually what you have to understand is who owns this from an administrative standpoint. Is it the facilities folks? Is it IT? Is it the physical security folks? Is it your data center folks? Because that matters, right? And you have to get that done first. So if you are a security person in an IT department, and you walk into the data center, or you walk into the physical security department, or you walk into the facilities department and say, hey, I want to do these audits, it's likely they report to someone else. They don't report to the CIO, or maybe they don't even, like, the CSO may not be in their direct chain. They may report to a COO, right, the facilities guys. Maybe sometimes they report to finance or whatever, right, because corporate real estate or whatever. So that's a really good point. So if you want to get your arms around this from a strategic perspective, you have to organize yourself to where you have control of these in a way that makes sense. So it may be under the CSO, it may be under the CIO. I don't know what that looks like for your organization, but you have to do something, right? Especially when a lot of the exposure is created by third parties, like the integrators, like we saw. Your building management system is going to be in an AT&T IP address space someplace. That's hard. That's a hard problem, right? So good question. So organizing yourself in a way to where the person that does have basically responsibility for these building management systems, it's clear to them that this falls under their responsibility. That is the first step. Before you do any technical stuff, from a strategic standpoint, that's the first step. And then once you have that in place, the rest of it can kind of fall into play, how you want to manage it, that sort of things. So we have seen some really interesting things where the responsibility has shifted hands. So for example, we go to some organization, I won't say which one, and we're like, hey, you have your building management systems online. And they're like, oh, we didn't know. And we're like, oh, yeah, it's an AT&T IP address space. And they're like, oh, okay, that's crazy. And then they go talk to the facilities folks and they're like, oh, yeah, we knew about this all the time, right? And then the IT folks, the CIO is like, you guys don't have any clue as to what you're doing. These are computer systems. We're taking them over. And so they took them over and they put them into, they didn't put them into the corp IT space, but they put them under the corp IT security policies. And then what they ended up finding is like, these devices act really weird. For example, you had HVAC controllers phoning home to places that are like unknown blacklists, and you had like all sorts of internet activity where like certain protocols were getting sent over the internet, right? And then they basically asked us like, should these devices ever be doing this? I'm like, no, they should never be doing that, right? And they didn't know this was happening because the responsibility was very unclear. And so facilities is running these things with literally servers under someone's desk, right, plugged into some Comcast modem someplace. And so all the other scrutiny that happens for egress filtering and all the other stuff is just being missed, right? So really good point, definitely. Yeah. Don't push the buttons on the internet-facing stuff. So don't do that, please. Anything else? Yeah. So that's a good question. I don't know. Like every building's different. And so depending on the components that are attached to, I don't know what could happen. So, because it's likely that your fans that run your HVAC, your boiler or whatever, those are probably different for every single building. So it's hard for me to generalize and just say, well, if you have access to a boiler, you could probably do this. What I'm thinking is you probably have to have like access to, the question should probably be more like, if you have access to this specific type of equipment configured in this way, what type of damage could you do, right? And so, or laid out in a certain configuration or whatever, I don't know. So, but we do have a project we're going to do this year where we're working with an integrator on the East Coast. And the integrator is basically, it's pretty cool because they go into new facilities and they set up building management systems, right? And they rip out all this old equipment. And what they're going to actually do is set up that old equipment into basically like a fake building management network. And we're going to try to see exactly what it is that we can do. Like whether we can set a boiler on fire or do crazy stuff, right? Because you can't do that during pen tests. So, but if we have equipment that they're going to throw away anyway or scrap, they don't have any problems with us doing damage to the systems, right? So, yeah, good question. I can tell you this. The systems are not designed to be messed with. So, like your boiler is not robust, and hopefully there's physical security mechanisms that prevent like catastrophic damage. But I'm pretty confident, like just being able to just break it, that's probably well within scope, probably pretty easy. So whether or not we can like set a building on fire or something like that, I don't know. That's what we're going to try to look at this year. But as far as just breaking equipment, I'm pretty sure you can just break it if you want to. So what that means to your business, I don't know. It depends on how your business is using your building management systems. So. What, like, can you repeat the question? Yeah, so that's a good point. I think a lot of folks don't realize that their building management systems can be controlled remotely. So the biggest problem is probably understanding that if you have a building management system, it's probably likely that your integrator is managing it remotely. So, I mean, that's why we see all these building management systems on the internet. Like the corporations don't put them there themselves. The integrator puts it there for them. So what's likely is if you want to restrict remote management to some of these systems, you probably have to work with your integrator. In fact, we've seen that every single time is the owning organization, the bank or whatever, they actually have to tell their integrator like, hey, look, you're not going to log into the web interface over the internet. You're going to ask us for access to this specific segment. We're going to allow it for a given point in time, and then you're going to do your remote management. And when you're done, we're going to turn it off. And so the integrator has to call. So they can still do remote management, but the organization can now control the remote management in a way that makes sense to them, right? So it's a good question. Yeah. I mean, at the end of the day, you know, what I tell integrators is like, hey, a VPN appliance is like a couple $100, you know? Get it in front of your devices because, in my opinion, they're not robust enough to be internet-facing, even if you have all the security mechanisms and configurations done correctly. I mean, as obvious by the exploits that we have, right? So I don't think having this thing on the internet is a good idea at all. Well, I hope you guys, there's... Yeah. Really bad. Basically, it's a question about patch management. Like, so for example, the Tritium Niagara boxes, there's patches for all the vulnerabilities that we had reported to them. If you look on the internet and you do the enumeration, the boxes will tell you what version they're running. You'll see that almost none of them are fully patched. So it's really poor. And why that's the case, I don't know. I don't know if it's because those devices are run by facilities, whether they actually belong to an integrator and they're just being leased by the end organization, or whether people just don't care. I'm not sure. But the reality is that if you find a device that's on the internet, it's probably not patched. Yeah. If you find it in your internal network, then it's probably really not patched ever, right? So, yeah. To do like just enumeration and that sort of stuff? Yeah, so the Nmap script, you can download that from Digital Bond's website. And then the Python script that I have, that's actually built into Shodan now. So, yeah. It's just the port. You just query for the port 1911, yeah. and you'll get a list of a bunch of stuff. Yeah, and then John hasn't hooked, the guy who runs Shodan, he hasn't hooked up query capabilities yet, but if you just query for that port, it'll just dump everything that it has that it's done in the last internet scan. It's like a couple, 10, 20,000 devices. So, yeah. And then, grep for your company name. So, if there's no more questions, thanks for attending. I really appreciate it. So, thanks, guys.